All right, distance learning week 6. Only got one more after this. Today we're going to take a look at trig functions with general angles, so not necessarily using right triangles anymore. They will be involved somehow, but a little less than they had been. So first thing, we're going to look at the new vocab. You'll see quadrantal angle, reference angle, law of sines. Solving a triangle, so you'll use the law of sines to solve a triangle. Ambiguous case, so that's kind of with the law of sines, there's an ambiguous case where you don't know exactly if it's going to even form a triangle or if it can even form two triangles or just one. And then the law of cosines as well to help you solve a triangle as well. So the first thing, trigonometric functions of general angles. So here we are looking at really more so them as more of a vector, which we haven't really talked much about, but a vector is a thing in physics that has a magnitude, so it's a length, and a direction. So that's what lines and how trig and physics relate. So in this case, we're just looking at a point out in our coordinate plane that has some y length and some x length, right? The ordered pair it's at, and you're just going to take that and divide it by the radius away, the distance away from the origin it is. So, still using a right triangle, you can see it in the image there, but now our y value is the y direction it is, and the opposite side is always the y. The adjacent side is always the x, and then the hypotenuse is the radius away. So here we are given one point at 8, negative 15. So our x value or our adjacent side is 8, and the opposite side is negative 15. So that negative is actually going to help us out in terms of knowing where that angle is in terms of the unit circle. So what we want to do here is just use the formula we just saw. So the radius, r, is equal to the square root of each of these squared. So the negative 15 squared plus, it's really just using Pythagorean theorem, right? So you can see it's a right triangle. This is 15, but we're calling it negative 15. It doesn't really matter because when you do the Pythagorean theorem, you square it, so it can be positive or negative. It doesn't really make a difference. And then the 8 up top. You're looking for the hypotenuse. So that 8 squared. So that gets us a square root of 225 plus 64. Which is 289. And the square root of 289 is a nice, pretty even 17. So it wants us to find the exact values of the 6 trig functions. So we need r in order to do that. Now we have it. We just need to use the formulas we just saw. So sine of theta is going to be equal to the y value, negative 15, over r, 17. Cosine of theta, don't even know what theta is, doesn't matter. We can find it, but we're not going to. Is going to be the 8 over 17. Tangent of theta is going to be our opposite over adjacent, which is y over x. So negative 15 over 8. Cosecant of theta is 17 over negative 15. Secant is 17 over 8. And cotangent is going to be 8 over negative 15. That simple. So now, the quadrantal angles are whenever it is like just a right angle, right? So going straight out to the right, that's 0 degrees or 0 radians. Going straight up, 90 degrees or pi over 2 radians. Straight out to the left, 180 degrees, pi radians. And straight down is 270 or 3 pi over 2 radians. So something special happens here. So notice as we go through here, for 0 degrees, it's r0. So whatever the length is your x, y is 0. Straight up, flips around, x is 0, r is whatever the value is that's out. Going to the left at 180, it's a negative r, 0, and going down, it's 0, negative r. So those two are the flipped versions of each other. So here you want to do the values of the 6 trig functions of this situation. So the same numbers apply every time. So it is at r, right? But let me show you what happens. So remember, sine of theta, even though we know it's 270, is the y amount, right, which is negative 2, over r, which is also negative 2. So that's just 1. And it is 1 every time we're going in that direction. For cosine of theta, remember again, cosine is x over r. So that's 0 over negative 2, or just 0. And again, true every time for 270. Doesn't matter how long it is. For tangent of theta, that was going to be y over x, right? So it's negative 2 over 0. Can't divide by 0. That's a problem. So this one is undefined. For cosecant, again, we're just going to flip what sine was, so it's still negative 2 over negative 2, or still 1. Secant is negative 2 over 0, so that's undefined. But cotangent is 0 over negative 2 now, so that's 0. So notice we got the same numbers twice throughout this, right? We got 1 twice, we got undefined twice, we got 0, 0. Actually, I need to take something back here. So r, remember, is going to be this, right? So the square root of y squared plus x squared. So in this case, that's going to be negative 2 squared plus 0 squared, which is the square root of 2 plus 0, not 2, sorry, 4. Plus square root of 4. R is 2, so it's actually the absolute value. So that's my bad on that one. So some signs are different on here, just for a couple of them. So it's a negative 1 and negative 1. That makes more sense. We're going down, right? So it should be negative. If we were going up, if it was at 90, it would be 1, 0, undefined 1, undefined 0. Since we're going down, it's negative 1, 0, undefined negative 1, undefined 0. Now if we're going out to the right, things would switch. So sine would be 0, cosine would be 1, and cosecant would be 0, and cotangent would be 1. And then if we went out to the, sorry, that's not accurate either. The undefined ones would change too. It's better if we just write that out, but I'm not going to show you. So these are the reference angles. So what this means is how far away it is to the nearest axis, basically. And specifically, we're more so looking at the x-axis, but you can use a reference angle to the y-axis. It's just common to use it to the nearest x-axis. So here you want to sketch each angle and then find its reference. So 330 degrees is just 30 degrees shy of being a full rotation, right? So it's all the way over here. About there. So the reference angle is the rest of it, that 30 degrees. So the reason this is important is because now, instead of doing sine of 330 degrees, I could just do sine of 30 degrees, and it'll give me the answer. It'll be off because it's going down that 30 degrees, but you just have to make sure you get signs right. Because sine in this quadrant is negative. We'll talk about that in a minute. So the next one, negative 5 pi over 6. That's not quite 2, or pi, right? It's less than pi, by 1/6, and it's negative. So it's actually going to go around this way to here. And our reference angle, again, is right here, pi over 6. So again, I could do sine of pi over 6, whatever I get with that, and again, making sure it's negative because sine is associated with the y. It's down below the x-axis, it's negative. So whatever I would get for sine of pi over 6, it'd be negative. That'd be 1/2, by the way, negative 1/2. So that's what we're going to look at next. So evaluating these trig functions, you can see in quadrant 1, everything's positive. In quadrant 2, sine and cosecant are positive, everything else is negative. Quadrant 3, sine or tangent and cotangent are positive, everything else is negative. And in quadrant 4, cosine and secant are positive, everything else is negative. So here what we need to do is figure out what the reference angles are for these, and then use that to find out what sine and cotangent are of their respective reference angles. Make note of where those are on the coordinate plane, and use the quadrant knowledge we just saw to figure out what they are. So sine of 135 is 3/4 of the way to 180, right? So if we divide that by 3, it'd be 45. So this is the same thing as sine of 45. 135 is also in the second quadrant, which is where sine is positive still. So this is just going to be a positive sine of 45. And if we remember back to our special right triangles, 45, 45, 90, sine of this is going to be x over x square root 2, or square root 2 over 2. For cotangent of 7 pi over 3, so that is greater than 2 pi, right? That's more than one full rotation. Because 2 pi would be 6 pi over 3. So this is 1 pi over 3 past that, right? Which means pi over 3 is our reference. So cotangent of pi over 3. So if we remember, this is a 30-60 situation. The pi over 3 associates with the 60-degree angle. So that means that the opposite of that, so cotangent is adjacent over opposite. So that's going to be x over x square root 3, or again, same kind of thing we had with the last one, square root 3 over 3. But now we need to figure out the sine of it, right? So cotangent pi over 3 and 7 pi over 3 is one full rotation, then another pi over 3 past the original position. So that means it's still in the first quadrant, which means this is positive, and that is our answer. So a little bit different now. We're going to look at a real-world example here. The swing arms of the ride pictured below are 89 feet long. Just FYI, this video is going to be kind of long because we have a lot to get through. The swing arms 89 feet long, and the height of the axis from which the arm swing is 99 feet. What is the total height of the ride at the peak of the arc? So what we're looking for is what y is, and then we're going to use y plus the 99 to figure out what the total height is. So that negative 200 degrees, again, means that this is 20 degrees inside of here. Because that's 180 plus another 20 to get to 180, or to 200. So what we're going to use is, at this point, the sine thing doesn't really make much of a difference here because we're just dealing with a real-world example. Negatives don't make sense. So we are looking at a sine situation. sine of 20 equal to y over 180. Not 180, 89. So then we multiply both sides by 89. We get y equal to 89 sine of 20. And we plug that in the calculator. Y is equal to, really, it doesn't matter what that is. Let's do this. The total height is equal to y plus 99, or 89 sine of 20 plus 99. So our height, our final answer, it doesn't say where to round, so we'll do nearest hundredth, 129.44 feet. So the area of a triangle, this equation here helps you to find the area of a triangle when you're not given the height. You might be given one of the bases, but that doesn't help when you don't have the height. And you don't really know the angles necessarily. So you might know one, but not all of them. So the formula for that, again, we're going to write that down here. Kind of just depends on what you're given. So here we are given angle A. So the area of a triangle is equal to 1/2 the other two sides. So in this case, it'd be side B and side C, because we don't know what side A is, times sine of angle A. So you multiply the two sides you know, and then the included angle, the angle in between them, in which case is A here. So now we are ready to go. So 1/2 of 6 times 3 times sine of 25. 6 times 3 is 18, so half of that's 9. So 9 times sine of 25. And we're ready for the calculator at this point. It says to round to the nearest tenth. And that is 3.8 square centimeters. So our next one is the law of sines. So this is a great one to use to solve a triangle if you're given specific information. So in this case, you are just dividing the sine of the angle over by the side opposite of it, and setting that equal to the same ratio for the other sides. So it's helpful to know the angles in this situation, or to know two sides and one angle, or two angles and one side, or two sides and one angle, hoping that those sides are across from the angles, that is. So in this case, we have a situation we can use it in. So we have the sine of 100 degrees over C. We want to solve the triangle, so we're trying to find everything that we don't know. So angle A and side A and side C. So we have everything for the B's. So that's what we'll use to find side C. And we still need to find angle A to find side A. So we'll do this first. We cross multiply. We get C times sine of 53 equal to 9 times sine of 100. Divide both sides by sine of 53. Now this does say to round the angles to the nearest, no it doesn't, never mind, nearest tenth, alright. Later on it'll say something like that where we round angles and sides differently, but we're not there yet. So now we're ready to go and just plug that in the calculator. We get side C to be equal to 11.1. And we don't have a unit, so that's it. So now angle A is easy to find because we have 2 out of 3 angles. So angle A is equal to the 180 that we know a triangle is, minus 100 plus 53, or 180 minus 153, which is just 27 degrees. Now we need to find side A. So we can either use what we got for C, but we rounded that, so I'd rather not. Angle A is nice and not rounded either, so we'll use that. So sine A, we just found it, so 27 over A equal to the same fraction we used for the B stuff, so sine of 53 over 9. Again, we're going to cross multiply. So it's A times sine of 53 equal to 9 times sine of 27. And again, we're going to divide both sides by sine of 53. Canceling that out and plugging the calculator gets us an A value of 5.1. So now, we didn't have this as a right triangle. We know it's not because none of the angles are 90 degrees, but we now know everything we can find about the triangle. So now, this is the ambiguous case situation. So there's all these different possibilities that could happen with a right or with a non-right triangle, right? Especially are in the side angle. So before we had two angles and we had one side missing or two sides missing, so that made it easier to find. You didn't have to worry about this situation. So now it all depends on what angle A is. So in these cases, it might not be labeled A, but you know. So if A, the side A is less than H, there's no solution. It can't connect, right? So that's what that first one is showing. This A is not long enough to reach down here. For the second situation where A is acute, it's exactly touching perpendicular, and it's when A is equal to H, the height. When A is acute, but the H is, so this used to have one solution here, no solutions, I can't remember, but I fixed it. So two solutions can happen whenever A is greater than H, but less than B. So here's B over here. A is between H and A, H and B, then it can land anywhere over here somewhere or out here somewhere. So it has to be less than B, but greater than H. And then if A is greater than or equal to B, then it's just an like out here somewhere, a very large line. If A is right or obtuse, there's only going to be either no solution or one solution. If angle A is right or obtuse. So that means that if A is less than or equal to B, then there's no solution. If A is greater than B, there's exactly one solution. So now we're going to do a situation with this. So we're going to do a couple problems with this, actually. So the first one here, it tells us that Q is 110, right? So since Q is obtuse, we have to look at what the 11 and the 8, right? So 11 is greater than 8, and that means we have one solution. If that 11 was less than 8, then we would have no solutions. So now that we know this situation's happening, we're ready to go. So now we can use the law of sines. So sine of n over 8 is equal to sine of q, which is 110, over 11. So we cross multiply. So we have all the sides, we're missing an angle, right? So 11 sine of n is equal to 8 sine of 110. We divide both sides by 11. Now, this one brings in an extra step. So we have to do the inverse sine to get n by itself. So it's the inverse sine of 8 sine of 110 divided by 11. So our n comes out to be about, now it says to round the angles to the nearest degree. I don't really like that, but we will. It's about 43 degrees. So now that we have two of our angles, we can find our third one, right? So n and q, so n or p here is equal to our 180 minus the sum of 110 plus 43, which oddly enough, is also 153 like we had before. So P is 27. So now we have all three of our angles. We have 2 out of 3 of our sides. We're ready to find side P now using our angle P. So sine of 27 over P is equal to, and at this point you can use either one, but I prefer to use the one that is the one we didn't mess with, so Q. So it's going to be sine of 110 over 11. Just in case you mess up, don't use things that weren't given to you. That way you can't mess up more, right? So we cross multiply, P times sine of 110 equal to 11 times sine of 27, dividing by sine of 110 on both sides. And our P value comes out to be, again, rounding to the nearest tenth for side lengths, and that is about 5.3. So we now have all three angles and all three sides. So our next one here, again, we got to figure out if we have 1, 2, or 0 possibilities for this. So looking at our sides here, we know that our angle E is 52 degrees. 52 is acute. So we still have all three possibilities. But now we need to look at what our height is and our side opposite of it. So E is 5, and our height, we don't know. So we do have to find our height. So what we're going to do is use sine of 52 is equal to the height, it's the opposite side, over our hypotenuse, 9. So we're using that right triangle that's from the dotted line over, from our height over. So our height is equal to 9 sine of 52, which is about 7.1. So 7.1 is greater than 5. The height is greater than the opposite side, which means that it will never cross. It'll just swing through here and never reach it, right? It will never reach down here, and that's a problem. So this one has no solution. So now one more example with this. It's very similar triangle-wise, but it did change a little bit. And we still need to find our height. So our angle is 28 degrees. 28 is acute. Right? So we still have all those possibilities. But we do know now that we need to find our height. Because if the height is greater than 9, then again it's just going to swing through there and never touch. So sine of 28 is equal to let's see, our height over 15. So the height is equal to 15 sine of 28, which is about 7.04. 7.04 is less than 9. So now we also need to look at it in comparison to the 9 compared to our other side, right? And so 9 is less than 15. So this means that we have two possibilities. Unfortunately. Because now we need to figure out if what happens when our y angle, or not y, but z, sorry, the other angle, is acute, and when z is obtuse. So there's those two different possibilities. So first one, if z is acute. So first thing we have is sine of 28 over 9 equal to sine of side z, or angle z, I mean, over 15. So we cross multiply. We get 9 sine of z equal to 15 sine of 28. Dividing both sides by 9. We have to do the inverse sine, so z is equal to the inverse sine of 15 sine of 28 over 9. So angle z comes out to be 51 degrees. So now that we have that, we have x, we need to find y. So angle y is equal to 180 minus the sum of 28 plus 51. Or 180 minus 79. So angle y is 101 degrees. So now we have our two angles that we were missing. We are still missing one side, right? We're missing what side y is. So we do our sine of our angle y over side y equal to, and we're going to use, this, again, the same one that we have given to us already. The sine of 28 over 9. So you cross multiply. Y times sine of 28 is equal to 9 times sine of 101, dividing both sides by sine of 28. Leaves us with just side y on the left, and we get, rounding to the nearest tenth, like it says to, 18.8. Now, this is what happens whenever z is acute. So I'm going to clear all this off for the obtuse version. Let me shift everything up so we have space. So that's if z is acute. So now, if z is obtuse. So this one gets a little tricky. So we would have to find what z is, and we know that if we take out the 51 degrees that it was before from our 180, that'll give us an angle of what z is. Z is 129. So what that did was it made it so that we went 1/2 circle around the unit circle and got us still an angle that gives us a z value that is the same if we did the sine of it, if that makes sense. So it's 129 degrees. So now we need to do the same thing we did before. The y value, the angle, is just 180 minus 28 plus 129. Which is just 23. So now we have our two angles already. And again, we are missing the one side, right? So just do one more round of the law of sines. We haven't even gotten the law of cosines yet. So sine of 23 over y is equal to, again, sine of 28 over 9. And we cross multiply. Oops. Sorry, clicked on the wrong thing. So we have y times sine of 28 equal to 9 times sine of 23. We divide both sides by sine of 28. And we get what our y value is, and that is about 7.5. So there are the two possibilities for this triangle. Lots of work for one problem. There it is. So now we're going to get a little bit simpler than that. This first one from there, a baseball is hit between second and third bases and is caught at point B, as shown in the figure. How far away from second base was the ball caught? So what we want to do here is use our law of sines, right? But we do know that angle B is just going to be 180 minus the sum of 41 plus 58, or 180 minus 99. Which is 81 degrees. So knowing that B is across from the 90 feet, we already know, but we don't know how far away the ball was from second base. So we're looking for what the side is opposite of third base. So we'll say A is here. We're looking for side A. So sine of 81 over 90 is equal to sine of 41 over A. A. So we cross multiply. A times sine of 81 is equal to 90 times sine of 41. We divide both sides by sine of 81. And A is equal to 59.8 feet. So now the law of cosines. So this one's a bit more complicated than the law of sines, but it makes it so you can really solve every kind of triangle now, no matter what. So here you're going to only use one angle with all three sides involved. So it's basically just squaring one side, setting it equal to the sum of the squares of the other two sides minus 2 times the two sides together. So the product of the two sides times cosine of the angle opposite of the side that was on the other side of the equal sign. Sounds more complicated than it is. So here we want to solve this triangle. We are given angle C and the two sides next to it. So that means we can find side C by squaring it, setting it equal to 7 squared plus 10 squared minus 2 times 7 times 10 times cosine of 73. Now we have everything on the right side, we're just missing C, right? And so to get rid of the square part, we can just square root everything that's over there. So 7 squared is 49, 10 squared is 100, 7 times 10 is 70, times 2 will be 140, cosine of 73. Made it a little bit easier by doing some of the work as we went, right? So that's going to be the square root of 149 minus 140 times cosine of 73. And at this point, the easiest thing to do is just plug in the calculator. So our side C comes out to be, again, rounding to the nearest tenth like we were before, 10.4. So now we have side C, we have all three sides we can use. Now we can go back and use the law of sines to find one of the other angles. So let's find angle A. So that's going to be sine of 73. Unfortunately, we do have to use the C we just got. And that's equal to sine of angle A over 7. So we cross multiply. And we have 10.4 sine of A equal to 7 sine of 73 We divide both sides by 10.4. And we're going to have to do our inverse sine. So A is equal to the inverse sine of 7 sine of 73 over 10.4. So angle A comes out to be about, again, rounding to the nearest degree, is right at 40 degrees. Now we're ready to go ahead and find the last angle we're missing, angle B, which is just 180 minus 40 plus 73. Or 180 minus 83, and angle B is 97 degrees. Oh, wait. Let's go back. I did that. Looking at the wrong problem. It's not 97. I wrote down the wrong numbers, too. It's not 83. Sorry about that. It's 113. And angle B is 67. There we go. Now it's all right. Now this problem. Oop. Forgot I'd already moved on to it. So this one, again, we're going to solve it. You're given all three sides this time. So we have to use, unfortunately, the law of sines to find an angle. That is where this one gets kind of ugly, because we have to do all that work and then do the inverse cosine. So it doesn't matter which side we start with. So let's just start with B, just for fun. So side B is 7. So 7 squared is equal to 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of B. So 7 squared is 49, equal to 81 plus 144 minus 2 times 9 is 18, or you can just multiply. 2 times 12 would be 108, and 108 times 2 is 216. Times cosine of B. Adding up, 49 is equal to 225. Minus 216 cosine of B. So we subtract 225 from both sides, and we get a negative 176 equal to negative 216 times cosine of B. We divide both sides by negative 216. And that gets us a fraction that's kind of ugly. So we'll leave it as the fraction. We'll get rid of the negatives, though. So B is equal to the inverse cosine of 176 over 216. And angle B comes out to be about 35 degrees. So now we have one of our angles. We can now use the law of sines. So sine of 35 over 7 is equal to sine of either of the other two angles. It doesn't really matter. A, let's say, over the side opposite of it, 9. So we cross multiply. So that's going to be 7 sine of A equal to 9 sine of 35. We divide both sides by 7. And we have to do inverse sine to get A of 9 sine of 35 over 7. A comes out to be about 48 degrees. And now we have those two angles. We can find our third one easy. So C is equal to 180 minus the sum 35 plus 48. Hopefully you know where I'm headed here at this point, because I gave you the answer a minute ago. Minus 83, and that's going to be 97. One problem left. So these are how you solve oblique triangles. We already kind of talked about it, but there's all the different ways, right? Using the law of sines when you're given two angles and any sides the law of sines if you're given two sides and an angle opposite of one of them. And then if you use the law of cosines, then you can then switch to the law of sines after you use the law of cosines once for those other two situations. So this last one, two pilots are in a stationary airplane, look 38 degrees to the left of their runway. So let's say, here's our plane, a crude drawing of a plane. They look to the left of their runway. This is their runway. And they see a bus. "75 feet away. Feet. And that angle is 38 degrees. Then they look to the right. "110 feet away and see a truck. It's a poorly drawn truck too. Not an artist. So now we have this triangle. It wants us to figure out how far away they are from each other, the trucks. So we'll call that X. So you're given the angle that's in between that. So X squared is equal to 75 squared plus 110 squared minus 2 times 75 times 110 times cosine of 28 plus 38, which would be 66 degrees. So lots of ugly numbers here, but X is going to be equal to the square root of all this. 75 squared is 5,625 plus 110 squared is 12,100 minus 2 times 75 times 110 is 16,500 times cosine of 66. We add some numbers up here. We get 17,725 minus 16,500 cosine of 66. At this point, the calculator is your best friend, and X is equal to 104. And it doesn't say where to round, so we'll do the hundredths, 95 feet. That's it.